All right, well, we're continuing with expression notes. Last time we worked on combining like terms and evaluating expressions. Today we're doing something else with expressions. It deals with the distributive property. This is something that should also be familiar from prior grade levels. So we're going to revisit it because this will be an essential foundational skill that we need to understand for our success in algebra. So what is the distributive property? It is, you have to multiply, typically we multiply a term with an expression. So let's give a visual for that. So an example, let's say our term is a, the variable a, and our expression, we'll put parentheses, and our expression is b plus c. When you have something like this, you're going to take a times each term multiplied by each term in the expression. So it's going to look like this. A times b, and typically we'll draw these looping arrows, and a times c. So we're going to put a times b. Instead of writing the multiplication sign, you can just put the variables next to each other. It still represents multiplication. And then we'll put plus a times c. Now, crucial here is sometimes I'll see students not put the positive sign, but the thing is we need to make sure that we separate these terms. There were two terms in our grouping symbol. There will be two terms after you multiply, considering that there's no like terms. All right. Before we get to our examples, there's some things that we need to know and also revisit multiplication rules. Things that we need to know. When you multiply variables, what happens here? If we have x times x, generally I'll get one of two answers. Students will say it's either 2x or it's this second thing that's correct. It is x squared. It's not 2x, right? 2x would be answering the question, what is x plus x? But what is x times x? What happens here is really an x, a variable, has an exponent of 1. When you multiply, as part of exponent properties that we'll revisit later, you add the exponents. So here, for x, m to the third times m to the second, let's expand it. Let's put in expanded notation. M to the third, m times m times m. Put that in one parentheses. And then m squared, m times m. I mean, all together, how many m's do we have? We have 5 m's that are being multiplied in various multiplication symbols. So this is m to the 5th power. Right? Instead of writing expanded form, we could have just said, all right, we multiply two terms. What do? We add their exponents. And then finally, we have a times b. We actually did this right up here. This is just ab. I can choose to put the multiplication symbol in between or not. Means the same thing. All right, and then getting on to multiplication rules, something that we've done in integer operations is when we multiply the same sign. A positive times a positive is a positive, and a negative times a negative is also positive. So pretty much when we multiply two terms and they're both the same sign, it is a positive. And then a second observation that we made is if the signs are different, either a negative times a positive or a positive times a negative. When they're ever different, it's a negative. And I could go into more in depth of why these properties happen, but for right now, that is the main observation. All right, so let's get to just quickly what is our examples. We're going to kind of start from maybe easy to hard if you want to think about it in those terms. All right, so first thing here, we have 4 times y and 4 times a negative 5. Or you can think of this as subtracting 5. I'm going to write it out. So 4 times y from here. And then now 4 times a negative 5, so I'll put plus. 4 times, I'll put negative 5 in parentheses since I don't want to confuse this with 4 minus 5. Now we can simplify 4 times y. It's just 4y. There's an expression that I use quite a bit, is that if you cannot simplify, you write what you see. I cannot simplify 4 times y, so I just wrote what I saw. It's just 4y. Second, we have a positive 4 times a negative 5. This is a negative 20. And this is something that I cannot simplify. These two things are not like terms. So I just write what I see. 4y minus 20. If that 20 had a y, sure, I can combine them. But this won't make, please resist the urge of simplifying this. This won't be negative 16y. You cannot combine that, right? This is equivalent to, let's say I had, I don't know, like 8 apples and I owe someone like 9 oranges. Like, you cannot combine apples and oranges in those terms and make it like an apple orange. Just not realistic here. So maybe think about it in those terms there. Example 2. Instead of writing out in this like product form like this, I'm actually just going to multiply it out mentally. So negative 7 times a positive 5. Negative times a positive is a negative. All right, we see that here. And this is negative 35. I'm going to treat this as a negative 7 and a negative 3x. What's a negative times a negative? It's a positive. And this is 7 times 3x. I'm just going to do 7 times 3, which is 21. And we'll just copy down the x at the end. Nothing happens with that. It kind of just tags along. This is our final answer. You could write it like this, or sometimes you might see it in maybe our textbook, something like this, where we have the signs or the terms switched. Right, these two things represent the same thing. We still have a positive 21x. We could put that plus sign, but many times you won't see it there. And we do have a negative 35, and we see that at the end. All right, so both these things equivalent. All right, moving on. G squared times g, just like what we were talking about up here. When you multiply variables, you add the exponents. This is technically an exponent of 2 and an exponent of 1 for this g. So g squared times g is g cubed, g to the third power. And then finally, g squared times a negative 11. You could think of this as like g squared and then a negative 11 at the end, but I'm going to put the negative 11 in front. Typically, we'll put our coefficient in front. The way you want to think about this is maybe in terms of money. Like, you could say that you have like $3, but like it's more kind of conventional to say that you have $3. Like, if you say $3, I know what you're saying, but that's why we put 11 in front of the g squared instead of like a g squared and an 11 there. All right, anyways. And then these two things do not simplify, right? Remember, for combining like terms, they do have the same variable, but they do not have the same exponent. So it did not simplify. We just write what we see. Okay. Moving on to the last example. All right, we have 5m squared times a negative 2m. So let's multiply the coefficients first. A positive 5 times a negative 2, that's a negative 10. And then now let's multiply our variables here. M squared times m is m to the third power. Now moving on to the last term. I didn't talk about this in these notes, but I did talk about it in the previous notes, where you can treat the coefficient of this as 1. So really you could say, like, what is 5 times 1? Or a positive 5 times a positive 1 is a positive 5. And then what is m squared times m to the third power? We actually did that same thing right here. That is m to the fifth power. Okay. So this, we can keep it like this. They have the same variable, not the same exponent. We cannot simplify. Or you could also write it like this in terms of when we get to polynomials, it'll probably be the expectation that you write it like this. This is called standard form, where we write it based on highest degree to lowest degree. Degree is exponent. But for right now, don't worry about it. These two things mean the same thing. All right. Anyways, that's going to be the notes. For our practice, you're going to go to Map Accelerator. If you're not sure how to access Map Accelerator, go to Canvas. And from there, you should see an icon that says Map Accelerator. And then for our class, you should see either an assignment or a series of skills. And then go and complete those. I believe it's either 4 or 7 problems you have to complete. And then from there, you just work on Prodigy. Okay. Anyways, you're always welcome to email me if you have any questions. Have a good day.